So we're here today. I got my friend Caleb. So we're gonna be making the sugar potassium nitrate rocket fuel. So, but we're gonna compare two items. We're gonna compare regular sugar with this concoction that my sister made in her baking school. It's a mixture of water, isomalt, which is a sugar substitute, which actually has 2 more hydrogen atoms per molecule than sugar does, with a little bit of food coloring. So we'll see if, like, when we're done with it, the food coloring makes a difference. And of course we have our potassium nitrate. So we'll be making mixtures, batches, with both potassium nitrate, regular sugar, and potassium nitrate, and melting this down and using this. And we'll see how it goes.
We're just going to use green isomalt and water mix. So
instead of just measuring out 40 grams, we're just going to pick a few pieces, measure it out, and then we're going to do some calculations to figure out what the 60-40 ratio is.
Oh, right.
Let's go.
Oh, yeah.
So we did the calculations, and now since we use 28 grams of the isomalt, it'll be a 70-gram total, which then we'll use, how many grams was it?
42 grams.
42 grams of potassium nitrate.
It never really occurred to us at first, but this is not granulated like this. So whenever we mix it with the potassium nitrate, we're not exactly sure what's going to happen, but we're just going to go with it, you know, got to roll with the punches. Hey.
So we're only like maybe a minute in, and we already got some melting and bubbling going on down here. So it's actually turning out really well. We hope that the potassium nitrate's mixed in with all the rest of it. There's only going to be one real way to find out when we light this stuff off. It's starting to burn. So, it's not green anymore. This is,
Maybe if you become super popular, you have to start encouraging safety. But maybe to get super popular, we don't encourage it.
Alright, so we came outside, clearly. Ooh, that was rough. Hold on. Alright, so we had it poured on the plate. It looks like poop, honestly.
Yeah.
So we're gonna see how well this lights off. Good.
Is not wanting to catch the flame here?
Oh my god! Oh!
Dude! Wow!
Look at the smoke!
Oh my god!
Look at the smoke!
I don't know that you'll ever be able to use that plate again!
Oh my god!
Uh-oh, hey neighbors! Woo! Wow, dude, that is so much better! Impurities rule!
So, we weren't expecting that reaction. Since I was sitting like literally right next to it, it scared the absolute crap out of me. Here's our plate. The foil.
Yeah.
It's gone.
Kind of non-existent now.
And
Oh well. Well,
the flame wasn't really colored. Yet again, we did kind of burn it. So maybe we can try it again. We'll do blue, and we won't let it get burnt this time. And we'll see if the smoke is blue. It's like homemade smoke bombs.
Yeah.
How's that? All right, so we'll see how that goes. No way.
What?
30 grams even.
No.
So we tried this again. We still got some blue left in there, but we kind of went a little longer once again. But all that means is that we just gotta do it one more time. So instead of using a barbecue lighter that time, we used sparklers, and as you see, it did light off instantly. This plate's still pretty warm, but we also noticed that time we tried to keep some of the color in there. We didn't try to keep it on the stovetop as long. We did notice that the pieces that did have the color, which is more in this area, burnt last, and there's still a lot of charcoal left over. So we think since there was still more color, it wasn't mixed in as well, you know, like the potassium nitrate, we don't think it was melted really very well at that point. So, sad enough, we probably won't get any colorful smoke. We did have a little blue tint, but we won't have colorful smoke as expected.
Yeah, so it just didn't burn as efficiently, I guess, so. Oh well. Alright, now we are going to do the final 60-40 mix with straight sucrose.
And potassium nitrate.
And, yes, and potassium nitrate.
Okay, honestly though, we're milling it, getting it all mixed up. This is our 60-40 100 gram mix, potassium nitrate, straight sugar.
Okay, so what we just burnt was our 60-40 ratio of pure sucrose and potassium nitrate, and as you can see, it worked. But I don't know, we didn't get the rate that we were expecting out of it, the burn rate. So perhaps if we toy with the composition a little bit, that might improve. We can just draw our own.
So now we see what the difference between the regular sugar had and the isomalt, which was the sculpting sugar that my sister had made. So it honestly seemed like the isomalt, the very first trial we had, burnt the fastest.
Definitely.
The second one, not so much, because we did
the second one wasn't as evenly mixed as the first one was.
right.
So,
And then our control ratio, the 60-40, was, it was alright. Like, I guess we could have mixed it in a little more, maybe. That probably could have changed the burn rate. But other than that, it was very exciting to see what the isomalt did, the colored sugars, and I was very pleased.
Me too.
Now we're gonna do something potentially dangerous. If that wasn't already.
You know what? Okay. Yep.
What? What did you do?
Oh, it did blow up. Yes. You see that?
Yeah. Still burning.
Wow.